we talked about an ordinary annuity, and there's actually two types of annuities. So I mentioned that an ordinary annuity is one where you have a stream of payments, and all of the payments are identical, and the payments are made at the end of the year. So whether they're payments or receipts, it's always done at the end of the period, if you're looking at a year or month or whatever time period you're looking at. The other type of annuity is called an annuity due. And that is one where the payments are made at the beginning of the year. And it's going to have a slightly different formula as a result of it. And there's reasons to use both. So for example, if you were projecting out the cash flow forecast of a company, you would use an ordinary annuity because you'd have to wait till the end of the year till all of the sales and revenues were collected. If you were, on the other hand, entering into a lease contract, most lease contracts require payments at the beginning of the period. So you would use an annuity due to calculate the present value of whatever lease payments that you're entering into. Rent off also is one of those types of things. So let's look at the formula for that. It's actually very similar to the first one. So the present value of the annuity due is equal to the payment, which is the amount of the annuity payment, times 1 minus 1 over 1 plus I to the n divided by I. So far it's identical. And then you multiply the whole thing by 1 plus I. So that's really the only difference. So everything on the right side is your present value factor. So the first half in the brackets doesn't change. You just make that adjustment by 1 plus I, which in this case is usually the inflation rate, to get to your PV factor. So if we were to do an example to calculate one of these, so let's look at a situation where we're trying to calculate the present value of $100 a year for 5 years. So same as last time, and this time it's going to be an annuity due. So the payments are going to be made at the beginning of the year, and the interest or inflation, whatever you want to call it, is 3%. Okay? And that's the discount rate that we're going to be using. So if the payments are at the beginning of the year, we use this formula. If the payments are at the end of the year, then we use the ordinary annuity formula. So then it's just simply a matter of plugging the numbers in to get the value. And the present value in this case is the payment of $100 times 1 minus 1 over 1 plus 0.03 to the power of 5, which is 5 years. So again, the inflation interest rate time period matches the number of years. And we multiply that by 1 plus 0.03. So at the end, we can calculate that into the payment of 100 times the annuity present value annuity factor of 4.7171. So it's just $471.71. So it's slightly different than the one we calculated last time. And you also have the option of using an annuity table to calculate this, and this would be the present value of an annuity due. So the table should specify whether it's an ordinary or an annuity due. So at 3%, 5 years, you get exactly that time or that PV factor of 4.7171. So you can use that as a method instead of the formula if you wish.